Hi everyone, I'm Roxanne and I work for the Eclipse Foundation. Benjamin is this week, so I'll be hosting this virtual IoT meetup. Today joining me is Henrik Fischer from Bosch Software Innovations. So he's going to talk to us about Eclipse Unide, which is really exciting because it's all about smarter manufacturing and Industry 4.0. If you have questions, you can ask us in the YouTube sidebar or on Twitter, #virtualIoT. So Henrik, take it away.
Thanks, Roxanne, and welcome to the meetup concerning Eclipse Unide. And the topic is a way to establish an open Industry 4.0 standard. I'm Henrik Fischer. I'm working at Bosch Software Innovations. I'm a solution architect, so more or less I do technical consulting for Industry 4.0 solutions, and also I'm a committer to Eclipse Unide, the project concerning our production performance management protocol, what I will explain later on. So I have a short agenda for this meetup today. At first, I want to explain what is Unide about and what is PPMP and what's the difference maybe between both. Also, I want to show you some tooling for Eclipse Unide with that we want to provide some validation functions, some visualization, and also I want to show you some implementation what we provide at the GitHub of Eclipse Unide. Then I will show you briefly how PPMP meets reality. So how we use PPMP in our real products for condition monitoring, for instance. And last but not least, I want to show you our next steps and do a short conclusion of that what you heard here in the meetup, and afterwards we can answer some questions. So what is Unide and what does Unide stands for? Unide stands for Understand Industry Devices. So we want to have something like a common language of all devices, like sensors or machines or robot arm stations. And this common language should be spoken by each of these devices, so you don't have to translate it, maybe to transform it, to convert it to another language. And this is what we want to achieve. Unide was created as an Eclipse project in August 2016 after our CEO, the CEO of Bosch, Volkmar Denner, published the production performance management protocol as a open standard in Industry 4.0 context. We want to provide some tools and implementations, for instance, to validate PPMP messages. So if the structure of your message you want to send via PPMP format is valid to the schema which is given by PPMP, we want to visualize and maybe persist some PPMP data where what you send. To have a quick feedback of the data you get out of your components, and we want to provide some bindings just for simple implementations with the PPMP. Also, and this is maybe the most important part of Eclipse Unide, is we want to provide a platform for the PPMP specification and for the further development of PPMP. So we want to use or to build up the community around Unide to develop it further, to get some experiences from other vendors, maybe of different manufacturing components, or from other business units or businesses like the energy business, and to develop it further in the community. Our target groups are small and medium enterprises, as well as big companies. But for small and medium enterprises, it's really important that we provide a simple and easy to use standard, so that we don't make it too complicated, like an OPC UA stack or one M2M, which has a specification of 100, 200, of 300 pages. This is not feasible for small enterprises to get through this and to implement such big protocols or such big standards. So this is our target group. And also we want to enable industry component manufacturers, for instance, like sensor manufacturers, to implement the production performance management protocol to their components, that they natively can speak this specification and can be understood by different IoT software. And also a target group, and this is because we are at Eclipse, are software developers. So we hope to get from the community some implementations from software developers who are interested in establishing this and make it bigger than it is now. So I spoke a lot about PPMP, and so I want to show you what PPMP is and what does it stand for. So PPMP stands for Production Performance Management Protocol, and this should be one open standard for Industry 4.0. So we know that this won't be the overall standard for everything what you can do in Industry 4.0. So, but it's a try to establish an easy way to get data out of the shop floor or maybe into the shop floor via a standard or given specification. So our focus is not the transport protocol itself. So for different use cases, you use different transport protocols. Like when you use a queuing mechanism, or you have to use a queuing mechanism because you have a lot of data which is sent to an IoT solution, and you want to provide protect your system from losing data, then you use a queuing mechanism, and therefore you can use a standard like MQTT. Or if you don't have that much messages which is sent from the shop floor to your IoT solution, you can use HTTP REST. So our focus is just the payload of the message and not the transport protocol, because there are established standards already there. Yet we have three defined message types. These are the machine messages, the measurement messages, and process messages. I will explain it in a few seconds, but these are the messages we already use in our Industry 4.0 solutions. So if there are more need on standardization of more messages like configuration messages or geolocalization, then we will maybe define by the community another message type. But this is the set of message types we want to start. And all the specification of the PPMP and the current valid specification of the PPMP you find under our Eclipse Unide project website under specification. There you see all the UML diagrams and explanations and examples for the different message types. So one of our PPMP messages is the machine message, and all the messages are structured like this one. You have a content spec where you have the identification, what is the content of this message about. In this case, this is the content spec of the machine message. And then you have an object, the device object. So this is the device, maybe the sensor or a station, a machine, which sends this data. So the origin of the data itself would be this device with an identification, the device ID. This could be an identifier you provide by yourself, or some serial number, maybe a MAC address. This the only thing we require is that this device ID is unique in your IoT context. And what we also can transport with this device object is the operational status. So maybe if your device is in maintenance mode or is working properly, you can set there, but you don't have to. And also what you don't have to use is the metadata field. And this is for sending some data which don't fit into the given properties of the individual objects. Like we did with some sensor manufacturers, they stored their IO link information to identify some IO link devices, for instance. On the right-hand side, you see the real content of the message. This is the message block or the message object, and here you can have more than one or just one. More than one is for collecting data and maybe to reduce the data traffic on your communication line. Then you can send more than one messages. When you just have one, then send only one. And what is required here is just the timestamp. So when the status or the error code maybe occur. And another thing is what's required is the code. This should be unique on your individual device type you want to look after. And you have also the possibility to give some additional information to the message itself. So you can set an origin if you have different sensors on your machine, and the device is your machine. Then you can set here your sensor ID, for instance. You can set a specific type. So is this message concerning a device, or is it just technical information? You can set a severity. Therefore, we have an enumeration with the given severities of high, medium, low, and maybe if you don't know, then set it to unknown. You can set a title and a description maybe, and also you're able to set a hint, maybe how to deal with such an error code or such a status. And also here you have the metadata field if you have information that you want to share but don't fit into the given properties, then you can set it here. The second message type we specified is the measurement payload. So the measurement payload consists as well of content spec and the device object. And also you can set information or transport information to the producing part yet. So when a machine is producing some part, some product, then you can set here some information concerning the part type within part type ID. You can set here the individual part ID like a serial number. You can transport the result of the manufacturing or the production itself. Is it okay or is it maybe not okay? Also, you can set an individual code, and what you also have here is a metadata field to send additional information. More interesting is the measurement object, or more than one measurement objects maybe. And there you can set a timestamp where the measurement series starts. So measurements are always time series values, so values that are related to a given timestamp. And this is required, obviously. And what you can also set here is a result on code what you have individually in your manufacturing context. And for transporting these time series data, you can set here your time series within $time. These are the offsets related to this start timestamp in milliseconds. So if you want to transport free measurement values which have an interval of maybe 50 milliseconds each, then you will set an $time array with 0, 50, and 100, and also the values related to this offset value individually. And what you also can set here is a limit. Maybe if you have some warning levels or error levels and you want to transport it to interpret your data you send out of the shop floor, then you can set here additionally some values for your limits, which can't be exceeded or something like that. The most complex but very important message or message type is the process message. So in the process payload, you have also the content spec and the device object, as well as in the machine messages or measurement messages, and you have the part object. And in addition to the part object of measurement message, you can set here a type, a part type. So is it just a single part what you're producing, or is it maybe a batch of parts, so a collection of parts what you are producing? For instance, if you have some painting processes, like we have painting of wiper arms, then these individual wiper arms are mounted on a rack, and the whole painting process is about the rack and not about the individual part. So you can set here this is a process concerning batch parts, and then you don't have to send for each individual part the same message. What is the most important thing of the process message is the process object itself. So therefore, you can set a start timestamp of the process, and you have to set it because this is required in the process. You can set an external process ID. This could be interesting when you have a lot of measurements during the processes that occur, and maybe these are too much measurements for one process message. Then you can split it up here and can identify all the measurements which come to the system by the external process ID. If you have two messages with one external process ID, then they are combined together. What you also can set here is the result of the process. So is it okay or not okay? And this would be the first, pardon. This would be the first check of your process, looking on the result. Is it okay, not okay? If not, then maybe you can compare two different processes and find the reason for getting an error or a process deviation. You can set here a shut-off phase if you have a measurement or a process which is splitted in different phases, and you have a phase where the ending of the process is set. Then you can set here the shut-off phase itself. And also you have here the metadata field for additional values. What do you have as information in addition to the normal process object is the program information with maybe an ID, name, or last change date. And this could be very important when you send process data and you have a process deviation from up to a certain timestamp, and you want to know where the process deviation comes from, then you can look on the program parameters and the last change date of the program, and maybe identify in that way why the process went wrong. And you can set here a couple of shutoff values. For instance, when you have a tightening process, you have a shutoff value at a specific torque. Please end up the process. So this shutoff value you can transfer or set here with the value, the timestamp when it occurs, and maybe also some upper and lower errors and warning levels. Where the measurements of the process itself, so what the process describes, are in this object. This is nearly the same like the measurement object in the measurement payload, but you have some additional fields which you have to use to characterize your process. You have the timestamp, like in the other measurements. You have maybe a name for your specific phase where you are in, or where the measurements come from. Maybe you have a pressing process, then you have a phase that the press goes down, and maybe you have a phase where the press release and it goes up again. Then you have two phases, and you can separate these phases in different measurement objects. You have a result flag and also a code property to transfer your individual code, for instance. And what you also have, and what could be important to evaluate the process on a fast way, are some special values. So you can set here some special values like minima or maxima, or maybe when you have such a pressing process, the holding time of a specific force, then you can set it here and maybe evaluate your process very, very quickly without looking into the whole process data you sent from the shop floor. And these whole process data you can set here as a list of or more than one lists of values. And the difference between this series object in the process payload and this one in the measurement payload is that you don't have to set here the time offset, because in specific processes or several processes, you don't have this information, and maybe you don't use this information. For a tightening process, it's not relevant to have a torque related to in time, but it's relevant to have torque related to an angle, and this is what you can compare between several processes. And also you can set here the limits. And in addition to the measurement payload, it's not just a single value for an upper or lower error or warning level, but just you can set here an array of values to maybe to have a cuff around your values you set there. Okay, these are all the message types we specified yet. And what is the difference now between Unide and PPMP? Yeah, the PPMP is just about these message types. So specifying these message types and have a strict structure of the message types. And Unide should be something which helps you to implement it, to test it, maybe to validate your PPMP usage in your specific component or is your specific software. So this is not only a client-server communication like displayed here, but this could be a way how the PPMP messages can be transported from the shop floor to the enterprise IT for maintenance support or condition monitoring, for instance. So for Eclipse Unide, we set up some tooling, and one of these toolings is a validation mechanism. So therefore, we have a JSON schema validation based on an HTTP server implemented by vertex. And you can send there some post requests within a specific PPMP body. So what you think is the right PPMP message, and you can set the parameter validate to true. And then you get an information back in the response body. If it is okay, then you get the status code 200. Or if something is not okay with the message you sent there, so if it's not valid to the given JSON schema, then you get an 400 status code back with a response body and your explanation what went wrong. For instance, I show you later on how this works at your machine maybe. And the schema itself or themselves are identified by this content spec. So every validation is due to this content spec, and the relevant schema is got by this spec here. Another tooling what we want to provide is some visualization. So therefore, we don't want to implement everything new, because there are some established and really good tools which are open and maybe easy to use. And one of these tools is Grafana. And we use Grafana, or we would recommend Grafana for visualizing measurements and machine messages. So this is really easy to use. You have a user management. You can get access to different like an InfluxDB, what we have implemented in the Unide project. And you don't have to use some SQL code, but just really easy to configure it. And Grafana is not that good for process messages, because process messages don't really relate to time, and therefore we set up a Node-RED dashboard simply to get data out of the database, process data out of the database, and have some charting and additional information what is this process about. And what we also want to provide, and what we still have within Java language, are some bindings or serialization functionalities for getting the object of the specific programming language out of the PPMP JSON you get, maybe, and the other way around. So we want to define these objects in the different languages, and just did it with the Java bindings what we provide at the repository at GitHub for Eclipse Unide. And this I will show you now. So I will open the repository at GitHub /Eclipse /Unide, and what you see here are our source codes, what we provide at this repository. So on the one hand, there's a binding for all the PPMP messages specified yet for Java, and also our server implementation for validation and persisting these data into an InfluxDB. And when you clone or download this repository, you will get these source code as a Maven project, and the first thing to use this project is to build it via Maven, and this I will show you now. I go to my repository and run the Maven command clean install, and then all the bindings and the server implementation will be built. And afterwards, for running this, you can run simply the fed jar, which comes out of the building process by Maven. And for this, you have to copy the application config, where you can set some parameters or properties for accessing a database, or for instance, your HTTP port where the server should run on. So therefore, we copy the application config JSON, which is in the resources included, into the target folder of our project. And when it is copied, we go to this target folder and we run this Maven project or the Unide server with Java -jar, then the fat jar and configuration where the parameters are located in. So we run this and you will see, okay, succeeded deploying vertical. This is a vertex implementation, so we have several endpoints for sending data to or getting some feedback from. So I will show you how to use it with a REST client. In this case, it's Postman because it's really easy to use. And when you don't know how to use it, you send just a post or a GET request to your endpoint. In my case, I host it on port 8080 at my local host, and I will get the information that no content spec is found. So I have to choose one content spec like this, and then I set the content spec for machine messages, just as an example how to use it. And then I post this information to no content spec found. Yeah, okay, because I wrote it in the wrong way. So, and then I will get the validation information by this content spec. So the JSON schema of a machine message is used, and I will get the information that the messages property is missing and the device property is missing. So if you don't have any clue about this information or about the PPMP message itself, you can write, okay, just messages, because this is missing, and also device is missing. So I will add here the device property in this case with an object, and I will get further information about what is still missing. And I see now, okay, device, there is a required property, device ID, and this is missing. So I will add the device ID to this object. And this is 123, for instance, and the messages should be an array. So I will add some array brackets here, and then I will get the information about the first message. In the messages array, there is still something missing. It's the timestamp and the code. So I will add the timestamp here, and this is ISO standard timestamp, some date 00, Zulu time, and maybe some code here. And this is also 123, and I will send it and get the information back. Okay, this is okay. This is a valid message I've sent there. And if I change anything in this message, I will get the information that there's something wrong in the message. And this is possible for all our specified message types, like measurement message as well as process messages. So this could be a way to implement and to test your own implementation of PPMP. What we also provide, if you don't want to host it on your own local machine, is a hosted Unide web server at an Eclipse Sandbox. And there we deployed this web server, which gives you these validation information for your PPMP messages, and also stores the data into an influx database, which we already have installed at this Sandbox server. And in addition to that, we also deployed a Grafana server for the visualization of measurement messages, and also a process dashboard to analyze maybe, or to get a visual feedback of your processes which you sent there with PPMP. First, maybe the Grafana dashboard, which is hosted on our Eclipse Unide Sandbox. And when you access that, you will get a test dashboard. On this test dashboard, you will get some information about maybe your CPU load, or whatever you want, and whatever you send to our Unide Sandbox, you will have access to, just to visualize your measurements. For this, I start some simulation application, and this sends data, for instance, my CPU load and memory usage, and also some simulated machine data to this sandbox with a sample rate of 100 milliseconds. And I think there is an interval of 500 milliseconds or 1 second. These individual values are collected together and sent then via a PPMP measurement message to the sandbox, and you get here some just visual feedback of some measurements. And what you can also do here is to visualize your machine messages, like some error codes, for instance. And you can see here the last error code which occurred, and also some history data here. And what we also want to show is how to visualize process data, and therefore we implemented some dashboard based on simple Node-RED. So you can access here this dashboard, which we host at the Eclipse Sandbox. And with this, you have easy way to visualize your measurements, which contained in the process message you sent there, and also some additional information of the process itself, maybe some part information. You can choose between the different devices you sent there, or where the data are from you sent there, and also you have a short history of the last processes, and you can select one, maybe to compare two processes together. So this is not the best solution, but it's a starting point to make a visualization of process data. A better solution is what I show you now, of course, and this topic I called PPMP meets reality. And this is our production performance manager, for instance, and this is where you see when you look at the name production performance management protocol and the name of the solution production performance manager, you see where the origin of PPMP comes from. And this is the generic interface of the production performance manager, because we need some a standard for getting data out of the shop floor into our IoT solution. And therefore we standardized the message types, machine messages, measurement messages, and last but not least, the process messages. And we use it for condition monitoring, just by evaluating measurement messages and machine messages, and also for process quality monitoring, for instance, based on these process messages. And how this should look like, or how this looks like, you can see here. If I show you just this software, and this is how you use these PPMP data so to compare processes. If you see, okay, there's a process and the result is not okay because here the column is red, then you can compare two processes, and maybe you find the reason for that this process was marked as a not okay process. And you see here, this is a welding process. There occurred some spatters, so you have to configure your machine better that these spatters don't occur, for instance. Or maybe just have to you want to create a standard process, and you want to compare each process message you get or each process you get to this standard process. You can build such a standard process by combining multiple processes together to have to have a limit curve, for instance, and every time when this limit curve is exceeded, you will get this information. Maybe. And what you also can do here is to evaluate just live measurements by using some rules. So you can set some limits, upper and lower limits. You can have a trend evaluation. If you see a trend, you will get informed, and so on. So this is the solution we provide to customers, and where we use the PPMP. And that we are not the only ones that use PPMP. You can see here, these are some vendors and contributors to Unide, and manufacturers which have PPMP implemented. There are some sensor manufacturers like SIG and Balluff, Gateway and MES manufacturers like Softing and ETAC. We have Stäubli already, which have the PPMP process messages implemented, or Promes, manufacturer of presses. And also internal Bosch business units like Bosch Rexroth have implemented the PPMP as the standard for communicating with IoT solutions. So this is not just a project in the open source community, but it's used in the reality. It's used in the industry 4.0. What we plan with Eclipse is to build up a testbed, and therefore we want to use existing open source projects like for DIAC, which have an implementation for PLCs, or Eclipse Cura, which provide some implementations for gateway applications. And on the other hand, we want to have an IoT cloud and offer some services. And the common language inside this whole ecosystem, from the shop floor with some machines to the IoT with Eclipse Kapua, for instance, the common language should be PPMP in that case. So this is a proposal for IoT Testbed we are planning currently. And now we want to start this testbed by using real machine data, and so we talk to different manufacturers, also to external manufacturers, maybe to get some real data from their machines. What are the next steps of Unide? Like I said, our main focus is on building up an ecosystem with the common language PPMP, then providing just source code or a lot of implementations. We just want to help an interested party to implement this PPMP in their systems. We are planning to specify maybe a PPMP version 3 to refactor the current offered message types, because they are based on our experience as Bosch Software Innovations, but we get more and more experiences from other vendors and manufacturers which leads to some changes in the existing specification. So maybe we will have a PPMP version 3. And what is also a next step is providing new implementations like an REST interface specification, like Swagger UI, to have a better overview over the existing endpoints and how PPMP should look like. We want to have a better process data storage and visualization. And maybe we want to have such an Node.js PPMP client to send and simulate data to a specific endpoint when you want to implement maybe in your own IoT solution the PPMP. And we also have some evaluation topics like the communication from the IoT to the machine, because at the moment we are only able to have the other way around with our current message types. And in this case, we also want to think about and discuss over further message types like geolocalization or machine meter information. Last but not least, I want to sum up this meetup a little bit. We have a few implementations provided yet. We have a Unite server hosted on a sandbox for testing and visualizing PPMP data, and also provided the source code for that for the usage on a local system. We have an increasing community, especially by industry component manufacturers like sensor pressing or robot manufacturers. And we are planning for build up an IoT testbed for smart manufacturing and industry 4.0 with the Eclipse Foundation. Thank you for your attention.
Thanks, Henrik, for this wonderful presentation, and thank you for joining us today to talk about Eclipse Unide. Thanks everyone for watching and for asking your questions. They'll be answered in the comments of the YouTube video. Remember to RSVP for 2 upcoming meetups on September 20th and October 11th. You'll find the details on the meetup page. See you next time.